Okay, so in this video we're going to have a wee look at how you read signals from an oscilloscope. There are really two things you can read from an oscilloscope. One is voltage and one is periodic time. So periodic time would lead you to get the frequency. So let's set up a signal first. So I'm going to connect my lead onto channel 1. So you see there are two channels on a scope. Channel 1 here, channel 2 here. So these are the two that we're interested in. This is not a signal we can see at the moment. So on this scope there are two ways you can get this to be a signal you can see. This scope has got an auto set function up here, or you can use the volts per division and what's called the time base to adjust this to see it. I'm going to switch off channel 2 just now by pressing that blue button. Switch that off. I'm going to adjust this so I can just see a couple of waves. So that would be an example of a signal there. So it's an AC signal, meaning it's alternating. You can see down here, it tells you the volts per division, in yellow for the yellow signal. If we had something on channel 2, it'd be in blue for the blue signal. So it's 2 volts per division. So 2 volts per division means every one of these big boxes here, like going from that centre grid line up, is 2 volts. So if you were saying how much does this measure in terms of peak, remembering that peak is from the midline to the top, you would count it up as being 2, 4, 6, not quite 7, if every box is worth 2, so you'd maybe think that was about 6.8. So 6.8 would probably be reasonable for the peak value of that signal. Peak to peak is twice as much as peak, or you measure from the very bottom to the very top. To do this, to get that on a line, you can use this, which changes your vertical, moves the position. So it's moved the midline from being here to being up here where that number 1 is. So now when you're counting on this, again it's 2, so peak to peak from the very bottom to the very top goes from here, 2, 4, 6, 8, 10, 12, more than 13, not quite 14, maybe about 13.5. And then you can put it back to being on the midline again by pressing this. That puts it back to the midline. So that's how you would measure peak from the middle to the top, or peak to peak from the top to the bottom, or from the bottom to the top, whichever way around. This scope also has a function where it will measure for you. So there's a button up here called measure, and if you press that, it will tell you what the peak volume is, which is down here, this maximum, 6.96, and the peak to peak, 13.7. They're quite similar to what we'd estimated from looking at it. You see that this value is constantly changing, whereas what we're seeing isn't constantly changing. So you can use the measure or do it by eye. I prefer to do it by eye. So 2 volts per division, 2, 4, 6, not quite 7, about 6.8. And then from the bottom to the top, counting again in 2s. And just shift that slightly to make it easy, so we're counting full boxes. So I've set that on my grid line, 2, 4, 6, 8, 10, 12, not as much as 14, more than 13 because 13 would be halfway, so maybe about 13 and a half. Then I can either move it back down like this or press this. And if I want to change my scale, I can change my scale using this. So now this is 5 volts per division, but you see it's less accurate. So looking at this, I would say that was maybe peak value 5, 6, 7 volts. And that would be how you would measure voltage. The peak and the peak to peak. The other two values that you get are values that you calculate. So the RMS, where you take the peak, the 6.8, and you multiply it by 0.707. And it's always 0.707 for RMS. And that gets you 4.8076. So you'd maybe write 4.81 for that. Volts, RMS. The The other thing you can be asked to do is to work out the average for voltage. And so again, you take your 6.8 and you multiply that by 0.637. Gets you 4.3316, which you'd probably round to being 4.33. That would get you your three significant figures. So let's look at voltage again, but let's change our signal. So I'm going to change it in terms of the frequency, and I'm going to change it in terms of the amplitude. So this scope will measure anything up to 60 megahertz. So it should be able to measure whatever I've got. There you go. I'm adjusting my volts per division here. And my time base. See if I can get anything. Let's see. What's the set on that? There we go. So that's a different signal from the last time. Get rid of that ribbon. That. Do a wee final adjustment on it. So again, I would use this control here, this volts per division. That's too large. The peak and the trough for the top and the bottom of the wave are outside the screen. That's probably your best one. And there's nothing else I can do. Signal's quite big. And again, you can adjust this way as well. We're only looking at that kind of vertical, not the horizontal just now. So this one's 5 volts a division. So in terms of peak, it'd be 5 up to here, 10, so that's 10 volts peak, 20 volts peak to peak. And again, if you wanted to find out the RMS, you would take the peak value of 10 and multiply that by 0.707. So it's 7.07 volts RMS, or 6.37 volts average. So that waveform could be described 4 ways in terms of voltage. 10 volts peak, 20 volts peak to peak, 7.07 volts RMS, or 6.37 volts average. Let's have a look at something quite small. So we'll adjust this one again. So we've changed to 2 volts a division, 1 volt a division, 500 millivolts, which is the same as half a volt a division. That's a way out of range, so this is too much. So that's where we should be there. We'll centre it. And I'm quite happy with the setting that way as well. I think that's easy enough to read. So now 500 millivolts, which is the same as half a volt. So going from the middle to the top, 500 millivolts, 1000 millivolts, or half a volt, 1 volt. So 1 volt peak, 2 volts peak to peak, 0.707 volts RMS, 0.637 volts average. Let's have another readjustment. Let's go for something maybe like that. And I'll adjust my time base so I can see this. Now this is just sitting right at the top and right at the bottom. That looks fine, or that looks fine, either or. Half a volt a division again, so going from the midline. Half a volt, 1 volt, 1.5 volts, 2 volts. 2 volts peak, 4 volts peak to peak, 2.828 volts RMS, and 2.548 volts average. So that's how you measure voltage on an oscilloscope.